All right, so a couple of you had questions about some of the intercept or the vertex forms, so I'm just going to work those really quickly. Specifically, you asked about 13 and 21, so let's look at those real quick. So number 13 is intercept form, x plus 3, x minus 3. And so, of course, remember with intercept form, it gives us the two intercepts. But we have to change those signs. So here, this is crossing the x-axis at -3 and at +3. So when I go to graph this, I'm going to go ahead and put those intercepts on the graph. Because A is positive, it should be opening up. And because it's 1, it should be an average width. So there's my -3 and my +3. Of course, now I need to find the vertex. And so to find the vertex, I need to add these two together and divide by 2, because what I want to do is find the middle of those 2 points. So I'm going to have -3 plus 3 divided by 2, which is of course 0, and 0 divided by anything other than 0 is 0. So that means that my axis of symmetry is here on the y-axis itself. And so now I want to take this x value and plug it back into my equation so that I can find out where on this axis of symmetry my vertex sits. So I'm going to say 0 plus 3 and 0 minus 3, which would give me 3 times -3, which would be -9. So all I'm going to do is come here and go down to 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, of course, just connect my parabola here. Get my buttons right. Okay, that's a terrible parabola, but just so you get the idea here. There we go. Much better. All right, and then number 21. 21 is 4, x minus 7, x plus 2. So again, what I'm going to do, this is intercept form. And so what I'm going to do is plot my intercepts first. So I have x equals 7 and x equals -2. I'm going to put those on my graph here. As I graph this, of course, my parabola is opening up because A is positive. And it's going to be kind of skinny because my A is bigger than 1, 3. Now all I need is to find the vertex, and remember to find this vertex, what I need to do. So add these together, 7 and -2, and of course divide by 2. And I get 5 over 2, and I'm going to guess you probably, the fraction threw you, 1, 2.5, but it's just 2.5. Come here and put my axis of symmetry. And now, of course, I need to plug this value in for the x's in my equation here. So I'm going to come to this other side here. Y equals 4. I have 5 over 2, which is 2.5, minus 7. And I have 5 over 2 plus 2. If you like the decimals, then we should get -4.5 and positive 4.5 here, and multiply those out. Let me get my calculator here. 81. It's actually -81, and I'm not going to go all the way down to 81, but I'm just going to kind of say, okay, let's say that this is 2.5 -81, and then I'm just going to connect. So there are those two in intercept form. And I think that's all the questions I got back from the asking you about the homework, so I hope everything else went well. If you have questions about the packet that you worked on, Well, you'll be watching this video tomorrow. So if you have questions about that packet that you did in class yesterday, um, if you will let me know and I'll work those out as well. I hope that working together you were able to figure those out and get those worked out. What I want to talk to you about today is domain and range, and it's a topic that you really hit in Algebra 1, but everybody always struggles with domain and range. But not only are we going to talk about domain and range, but we're also going to talk about a new way to write domain and range. So before I actually talk about domain and range, what I want to do is talk to you for just a second about what we call interval notation. And this is just another way that we can express inequalities. Okay, and if you don't remember what an inequality is, that's like x is greater than 0 or x is less than or equal to 2 or anything of that sort. And we can use interval notation to express this. It's kind of a little more fancy way to express things like this. So we're not always saying, oh, x is less than or x is greater than. And then we've got our little compound inequalities. But we're going to talk about all that. So the first thing I want you to think about is back when you first learned about inequalities and you were on a number line. Okay. Excuse me. And this number line represented x. And if I told you to graph x is less than 5, right? You would have 0, 1, 2, 3, 4, 5. And you had to think about a couple of things. You had to think about, am I going to have an open or a closed dot at 5, right? Because we know that this means it does not include. Okay, so those are the signs that are greater than or less than. Whereas we use a filled in dot to indicate that it does include. Okay, so those are things like less than or equal to or greater than or equal to. So if I look at this x is less than 5, because there's no line under here, that means it does not include 5. So I'm just going to put an open dot on 5. And now I have to decide which way do I go. Well, which way gets less than? Okay, less than always goes left. And this is assuming when the variable is written first. Okay, so that's a little trick there to remember which way it goes. But if the variable is written first and your inequality like it is here, less than means left, so I'm going to draw my arrow this way. Okay, one more. Let's say I had x is greater than or equal to negative 2. A little on my number line. And I'm just going to do the negative 2 because we don't need all those other numbers on there. But just for the sake of example, here, this is, of course, colored in because of the inclusion here. So that means it includes negative 2. And I'm greater than, so I'm going to go to the right because this is the way that the numbers get bigger. Now, I hope this is a little bit of a review for you and that you don't really need all of that. But if you do, there it is. So let me tell you about interval notation. I'll go back up here for just a second. I talked about the open and the closed dot, right, as compared to the inclusive or exclusive. So in interval notation, we use brackets and parentheses. So instead of an open dot here, this would be a parenthesis, either open this way or this way. And the inclusive would be a bracket opened one of these two ways. Okay, and let me show you what I mean by that. If I'm on this 5 here, I'd open the bracket or parenthesis with the way that the arrow goes. So in other words, here, this does not include, so it's definitely going to be a parenthesis, but should I open it this way or should I open it this way? Well, you want it to kind of encompass those numbers in the direction that it goes. So I want to open it this way so that it includes all of these numbers, okay? Here, for this one down here, because it's included, I'm going to use the bracket, and of course I would go this way because that's the way my arrows go. Now, We haven't written it yet in interval notation. We've just kind of determined what our signs are going to look like. Here's what we do in interval notation. We write it as a set of numbers. So we're going to have either a bracket or parenthesis with a number, a comma, and a number with another bracket or parenthesis, okay? This is the smallest value that we have, and this is the largest value that we can be. And if you look on your number line, you might be thinking, no, wait. If I look at this very first one, the smallest or the biggest, well, the smallest goes on forever, right? I know the biggest I can be here is 5, and 5 has a parenthesis on it. But what is the smallest that I can be? Well, the smallest here when we're on a number line, if it goes on forever in this direction, we say that it's negative infinity. If it goes off forever to the right, we say that it's positive infinity, and you don't have to draw the positive sign on the positive infinity, but you do want to include the negative on the negative infinity. So here, the smallest it can ever be is negative infinity because it goes on forever and ever and ever. The biggest it can be is 5, and that gets a parenthesis. Now, remember I told you this had to have a parenthesis or a bracket? Every infinity or negative infinity, always get a parenthesis. One way or the other, they always get a parenthesis because you can't actually be infinity. Okay, so let's look at this other one, this -2 to infinity. As I go here, the smallest that my x value can be is -2. That gets a bracket because it includes, and it goes up until you get to infinity. And of course, that's a parenthesis. Let's say I had x's. Let's do a compound inequality. This is an OR. And so we haven't talked about how to put two inequalities together like this. All right, to join two inequalities, we're going to use a U symbol, okay? This means union. It combines two sets of numbers. So when we use this U, it lets us hook two things together. So essentially what we're going to do is we're going to write these two inequalities and we're going to smush them together with a U, okay? So you don't have to do this on a number line first, but sometimes it's helpful to see it as you're getting used to interval notation. But this is saying less than 5, so open circle because it's not inclusive, less than 5, and then included 7, but greater than is going to go this way. So what I have here, remember, negative infinity to the left, infinity to the right. So I have here, this is negative infinity up until 5, and it stops. I'll do a parenthesis. And I'm going to throw that U in the middle like we talked about, because that's going to join another set of the numbers. And essentially what it says is skip all this, pick back up at 7, and go until the end. So this would be my bracket, and this would be my parentheses. It could also be that you have some values that are just between two numbers. So that's what we call another type of compound inequality. Let's say it was -4 to 0. This is -4 and this is 0. This inequality is an AND inequality, and it says just take all the values in between. X has got to be bigger than -4 while at the same time being smaller than 0, which will be all these values in between, right? And I have closed dots because they're inclusive, and closed dots we know means brackets, and the brackets are going to open towards the numbers that are included. So this, remember, smallest to biggest, this in interval notation would be -4 to 0, and I'm going to close that off that way. One other scenario to show you before we jump into domain and range. Sometimes you want to include everything except just one number. In other words, I want to say, well, X cannot be, let's say, 5. Okay? How would I represent that in interval notation? Well, if I'm on a line and here's 5, I want everything bigger than 5. I want everything smaller than 5, right? But I just don't want 5. So what I do is I put an open circle at 5, okay? Because that says take everything except for exactly 5. And remember, with open circles here, we're going to let that be parentheses that open in the direction of which the numbers are included. So here to write this in interval notation, I would be going from negative infinity up to 5. I'm going to join that, and I'm going to say 5 to infinity. Remember, this U tells us what to leave out, and we're leaving out exactly 5. It can't, the parentheses tell us that it can't be 5, but I still pick up with everything else but. All right, take yourself just a couple seconds, and then we'll pick back up with DomainRange. We have talked about in range of functions using this new interval notation that we just learned. So remember, when we talked about this, domain describes x values, whereas range describes the y values. Okay. Now, range we're going to look at visually, and we are going to decide from the graph what the range is going to be. But for the domain, we're going to take a little more algebraic approach to determine what the domain is. Now, for the parabolas that we're doing and the quadratic functions that we're doing right now, we're not really going to have any domain restrictions, but things that we're going to be looking for in the future are going to be fractions, because denominators cannot be 0. And radicals, because square roots can't be negative underneath. Okay, so we're looking for these two things so we can look. Remember, we're thinking about a number line, and we're thinking about maybe here anything that we need to leave out of the domain because it can't, the bottom can't be 0. Or maybe we're looking for any situations where x needs to be bigger or smaller than a number, than a certain value. Now, if that doesn't make perfect sense just yet, that's okay. I understand, and we will definitely be building on this as we go. This is just an introduction. We are going to do the domain and range of all of our functions, all of our quadratic functions that we've done. So range, whenever I say visual, I always like to describe this as bottoms up. I look at the lowest value on the graph itself and then go up to the highest value. So let's just start with a quadratic and let's look at what's happening here. Let's say I have this graph. Let's say my parabola has a vertex of 2, 3, and it's opening up. Okay, so domain, and I probably should have put this on here too. If range is bottoms up, domain is left to right. And again, most of the time we're going to be algebraic with this, but just so you get the feel of it right now. In my quadratic here, from the left to the right, is there ever any place that you could go left to right on this x-axis where there would not be a piece of a graph that corresponds to that x? In other words, if x was 20, well, it may be way, way, way up high, but there's going to be a value that goes with it, right? So there's always a value for every single x on this graph. There is a y that goes with it. So we say here that the domain is negative infinity to infinity. Here, and this is just how we indicate there are no restrictions. It can be anything you want it to be. For the range, remember we want smallest to biggest, right? Bottoms up. So if I look from the bottom up, I go. There's no graph here, right? If this is my y value, let's say that's -5, there's no graph that goes with that. So that's not in my range. That's not a value that's in my range. In fact, my y's, the smallest value that y can ever be is 3. It never goes lower than that. So the lowest it goes is 3. And I need to put a bracket because it includes that. That vertex sits at 3, so it's included. So I'm going to go from 3 all the way up to infinity because it keeps going up forever and ever. Alright, let's do another. Let's say this vertex is 4, 5, and I want the domain range. So of course the domain here, and this is true for all quadratics have a domain of, when that recording cut off, I'm really sorry. All quadratics have the domain of -infinity to infinity. So the domain here is -infinity to infinity of this quadratic that's going down. And now for the range, again, bottoms up. So the lowest it ever goes, and notice it's going down forever. That's what these arrows mean, right? This is not an endpoint. That is, in fact, just indicating that the graph goes on and on forever. So the smallest it can be is -infinity, and then I go up and up and up and up and up and up until I hit this point right here, which, remember, I'm talking about y values. So it goes up to 5, and I do need a bracket because it does include. All right, so here's what we're going to do. I am going to post you some domain and range work for you to get done. And if you have any questions, if you will send those to me, and that way I'll work those out for you so that you can see.